Hierarchical clustering is a type of unsupervised machine learning algorithm used to group a dataset of patterns or objects into clusters. The goal is to find the most meaningful structure within the data. The algorithm is bottom-up and can be divided into two main approaches: agglomerative and divisive. Agglomerative hierarchical clustering starts with each pattern being represented as its own cluster. For each iteration, the algorithm finds the best pair to merge, based on some similarity criteria, and updates the cluster assignments by merging the two clusters. This process continues until all patterns have been merged into one. The resulting tree or dendrogram illustrates the distances between single clusters and their neighbors. Divisive hierarchical clustering starts with all patterns in one large cluster and iteratively divides them into smaller clusters by cutting the data along some distance metric. Each division yields two new clusters that are then further subdivided until all the data points are in separate clusters. Again, this process produces a tree-like structure that is simple to interpret and analyze. When applying hierarchical clustering, a distance or similarity measure between clusters and observations must be determined. The most commonly used metric is the Euclidean distance, which compares the difference between 2 points in space and assigns a single number that reflects the magnitude of the difference. Other metrics can include Manhattan distance, the Bray-Curtis distance, and the Pesson correlation coefficient. In addition, the type of hierarchical clustering algorithm must be selected: complete, single, average, or Ward's method. Complete linkage calculates the distance between clusters as the greatest distance between any 2 points of the clusters being compared. Single linkage works similarly, but considers the closest pair of points instead of the greatest distance. Average linkage views the average distance between all pairs of points rather than the maximal distance. Ward's method considers the variance of points in both the clusters being compared. Hierarchical clustering is especially valuable in exploratory data analysis, as it allows humans to get a better understanding of the data, not just individual observations. By visualizing the dendrogram, analysts can easily interpret which data points are similar and locate natural clusters of related observations. Furthermore, since hierarchical clustering does not require large datasets, it is often used to help analyze smaller datasets or datasets with unknown numbers of clusters. Despite its value, it is important to remember that the outcomes of hierarchical clustering are only as good as the data, similarity measure, and clustering algorithm used.